Hello, this is Mrs. Davis. This is a pre-cal. We are working on Unit 3B, the chapter review, and we're starting with problem number 20. We have some new directions here. It says find the equivalent representations of the following expressions using sum and difference formulas and double angle formulas. So those identities we have to know. So let's just start out with the first one, number 20. We have a double angle for sine, and the identity is sine of 2x is equal to 2 sine x cosine x. So we'll just say that this is 3 times 2 sine x cosine x. So f of x would become 6 sine x cosine x. Next one, we have a cosine 2x. Now we have 3 different ways to write this. So remember, this is the one that has 3 important identities associated with it, and they're really used in calculus. So go ahead and learn them all. You need them at different times for different things. So the first one would be g of x is equal to 5, and then cosine 2x would be cosine squared x minus sine squared x. We also have one that would be 5, and then it would be 2 cosine squared x minus 1. And the last one is 5, and it's 1 minus 2 sine squared x. Let me redo that because there's not like a negative up there. Sine squared x. So don't forget these have 2's in them when you rewrite those. All right, so you could do any of those for that one. Now they have us actually use the sum identity for sine, and they give us very nicely, they break up sine pi over 12 as pi over 4. That's, 3 pi over 12 plus 4 pi over 12. Right? So we would say, okay, then I would have sine pi over 4 cosine pi over 3 plus cosine pi over 4 sine of pi over 3. And the sine of pi over 4 is the square root of 2 over 2 times cosine of pi over 3 is times 1/2 plus cosine of pi over 4, which would be square root of 2 over 2, and sine of pi over 3 is square root of 3 over 2. So you get 2 plus the square root of 6, square root of 2 plus square root of 6, over 4. So that would be the equivalent using that identity. All right, next one, we have cosine, and we're subtracting, which if you remember, this is when you add with the cosine difference identity. So this would be cosine pi over 4, let's do it in the right order. Cosine pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4, using that identity. So this would be 1/2 times the square root of 2 over 2 plus the square root of 3 over 2 times the square root of 2 over 2. And you get the same thing, square root of 2 plus the square root of 6 over 4. All right, let's move on. Let's go to next directions say to convert the coordinates, and we're going first from polar to rectangular, and then down here we'll go rectangular to polar. Okay, so let's go back here, and we'll remember that our formulas for converting x is equal to r cosine theta and y equals r sine theta. So that means that x is 5 times the cosine of 7 pi over 6, which is 5 times negative square root of 3 over 2. And y would be 5 times the sine of 7 pi over 6, which is 5 times negative 1/2. So you're left with the rectangular coordinates of negative 5 square root of 3 over 2, and then negative 5 halves. Okay, and that's quadrant 3, and you know that should be both x and y negative. Let's go to number 25. We have negative 3 as r and 2 pi over 3 as theta. So this would be negative 3 cosine of 2 pi over 3 and negative 3 sine of 2 pi over 3. So that's negative 3 times negative 1/2, using my unit circle, and negative 3 times positive square root of 3 over 2. So I'm left with 3 halves and negative 3 square root of 3 over 2. Negative 3 square root of 3 over 2. All right, so that would be my answer for number 25. Let's go on to number 26. We're going backwards now from rectangular to polar. So now we have to remember that r is the square root of x squared plus y squared. So r would be the square root of 4 plus 12, which is the square root of 16, which is 4. So we have r is 4. So if we're putting this down here, we have 4, comma, and now we're going to figure out theta. And the way to figure out theta is the inverse tan of y over x, so negative 2 square root of 3 over 2. So that's equal to the inverse tan of, they set this up nicely, negative square root of 3. Now negative square root of 3 is in quadrant 4. Remember, tangent can only be in quadrants 1 and 4, so it would be negative pi over 3. So this is negative pi over 3. Now, there are 3 others that you can use, because you know how when you made the polar point, there's always 4. There's 4 ways to identify each point on the polar plane. So you could go around and go backwards, etc., to get the other ones for that. So there's 3 others that you could write. Let's look at number 27. Again, r would be the square root of 3 plus 1, which is going to be the square root of 4 or 2. And theta is the inverse tan of negative 1 over the square root of 3, which is inverse tan of negative square root of 3 over 3 is how we know our tans. Now, again, I'm negative, and it's the square root of 3 over 3 one, so that's equal to negative pi over 6. So my point that I picked is 2 negative pi over 6. And of course, there are 3 others. You don't have to write them for this question, but there are 3 others. Let's just do one so you know what we're talking about. So remember, so if I have this as my pi over 6, so I'm at negative pi over 6, which is here, right? And I'm at 2. That's going to be where my point is, right? Now, another way I could write that point is 2, and I could go all the way this way. So you could also have 2, and that would be 5 pi over 6, right? You could write it that way too. And there's other ways. You could go backwards with negative 2's now, but you know how to do that. So All right, let's move on. Now this says, the next one says convert r equals 5 to rectangular form. So this is an equation in polar form and it's just r equals 5, which means that your r value, your distance from the pole, is always going to be 5, which is the equation of a circle. And remember, it would be at 0 if it's just r equals 5. So x squared plus y squared is equal to 25. And if you forgot, you know how to do that. R is x squared plus y squared is r squared. So x squared plus y squared is 25 is your formula for r anyway, using the Pythagorean theorem when we did that, right? R is the square root of x squared plus y squared. So let's just quickly identify this as a circle with a radius 5 at center 0, 0. So now let's go over here to the second one of this type, and it says let r equal 2 cosine theta. Well, we need x. And, well, because we have cosine theta, so we need r here. So let's multiply both sides by r. So we get r squared is 2r cosine theta, which means r squared is 2x. And r squared is x squared plus y squared. So we have x squared plus y squared equals 2x. And now we have to put that in our circle formula using completing the square, right? So we're going to say x squared minus 2x plus y squared equals 0. So then you're going to complete the square. You only have to do it for the x term. So you'd say x squared minus 2x plus 1 plus y squared equals 0 plus 1. So x minus 1, quantity squared, plus y squared is equal to 1. So this is a circle with the center at 1, 0, and a radius 1. So x minus 1 squared plus y squared is our conversion, and it is a circle with a center at 1, 0, and a radius of 1. All right, that is 20 through 29.